Oil and Gas Discoverer, Direct Detection Technology. Welcome to the Oil and Gas Discoverer website, where we have presented a more detailed explanation along with new illustrations of our unique, proprietary and environmentally benign space-based technology, Direct Detection Technology. Our website will offer you a more comprehensive understanding of our geophysical technology and can provide a better technology for your exploration. The use of DDT will save a great deal of time, cost less money, and will provide definitive information as to whether you have a reliable economic resource. The initial two illustrations are a representation of the typical helicopter tracks used when performing a DDT Stage 2 survey, and a 3D illustration of the subsurface hydrocarbon-bearing formations identified by analysis of the intrinsic radiation anomalies on the left side compared to the stratigraphic column on the right side provided by a customer based on their geological work plus their 2D and 3D seismic interpretations, as well as the result of their initial well drilling. Our hope is that the following revision of the website will offer you a better understanding of our technology. Direct Detection Technology. Our goal as Oil and Gas Discoverer LLC is to bring geophysical surveys into the modern world, the world of internet applications and on-demand web services. Our revolutionary satellite imaging technology has helped customers detect the presence of copper, gold, silver, diamonds, REE, as well as oil and gas-bearing reservoirs for over 20 years at a fraction of the cost and time of conventional exploration methods. In 2015, we revamped our field survey equipment and redesigned our image processing nanotechnology to its fifth and most advanced generation. In the past, we handcrafted each survey on a case-by-case basis. Now, we want to expand our reach to customers from all across the globe who will require nothing more than access to the internet. With your help, we can deliver high-accuracy, low-cost DDT geophysical surveys to customers 5 to 10 times faster than all competing survey methodologies. Customers will survey their land as fast as they can Google. Well, almost. DDT advantages. Number 1. Eco-friendly. Traditional exploration requires performing seismic exploration that can result in the potential harm to ecosystems and follow-on drilling of test holes. Number 2. Risk-free. Conventional surveyors must require land rights, permits, and other legal prerequisites before a survey can be performed. Using DDT's non-invasive approach, OGD can execute surveys prior to assuming those risks. Number 3. Fast. Typical surveys of 10,000 kilometers squared require approximately 2 to 3 years to complete. Using DDT, our technology can reduce this to 6 months or less. And number 4, precise. DDT can provide critical data regarding the mass and depth of each deposit, thereby eliminating false positives. Reduce the cost of geophysical surveys. DDT Stage 1 surveys can best be performed in the early stages of an exploration project. In fact, before any extensive geological, geochemical, and/or traditional geophysical methods are conducted. The results of DDT Stage 1 surveys allow one to establish the fact of whether the targeted underground resource, for example hydrocarbons, is present or not in the surveyed territory and how it is territorially confined. This provides invaluable information to guide the planning and placement of traditional exploration surveys. Science behind DDT. Every element in the Earth's crust exists in an excited state and emits an intrinsic radiation spectrum. This spectrum has a unique amplitude, frequency, and phase. Gold, silver, copper, coal, diamonds, REE, and hydrocarbon sources all generate intrinsic emissions which leave distinctive signatures or echoes. We can observe these echoes on satellite images processed in our laboratory. Direct detection technology was developed to discover these mineral resources, and it does so by tracking the reflections and echoes of their intrinsic emissions reflected on satellite imagery. Looking at this diagram, you can see that A represents hydrocarbon deposits, B represents schematic of formation of the energy cluster, C represents satellite, and D represents the Earth's surface. A three-dimensional approach. Similar to the development of seismic exploration data collection and presentation, OGD advanced from 2D to 3D presentations of DDT data in 2015, with the conversion of our software and equipment to 5th generation data collection and analysis. The 5th generation of DDT data in 3D is provided in the A-B combination in the figure to the right. An example of the same customer survey area with our earlier generations of DDT data in 2D is presented in the C portion of this figure. Note, the blue-lined areas in A, B, and C, which designates the customer's concessions, while the red-lined area indicates the primary area covered by the DDT surveys. The offshore versus onshore concessions are clearly identified in B. Predominant red areas in A and C indicate the highest hydrocarbon intrinsic radiation anomalies. However, a significant number of the high-intensity anomalies occur outside the customer's concessions. Based on the 3D data presentation in A-B, the lack of hydrocarbon anomalies offshore is readily apparent versus the questionable small red areas in the 2D data presentation in C. In addition, the 3D data presentation in A provides an excellent representation of the hydrocarbon intrinsic radiation spectra with its frequency and amplitude readily apparent. Setup: satellite. Analog satellite images obtained from space are collected and sent back to Earth. First stage: data processing. In the OGD laboratory, DDT records and identifies all unique mineral spectra. This is critical because it eliminates the possibility of mistaking any mineral for one of its isotopes, coal carbon versus diamond carbon, for example. Despite the similarity of their chemical compositions, their intrinsic radiation spectra reveal differences which make it possible to distinguish them. Second stage: flyover survey. DDT is a proprietary technology which we've used in geophysical surveys for more than 20 years. Today, with the rapid improvement of microchip technology and vast increase in computing power, DDT is presently using 5th generation satellite image processing and survey equipment, which we've tested and successfully employed since 2015. Proprietary technology. One of the important characteristics of the DDT field equipment is that we design, build, and incorporate monospectrometers in our field equipment. The monospectrometer is integrated into one of the components of the field equipment and is calibrated for specific or a particular single element or compound that is being sought in the Earth's subsurface. Direct detection technology. Evolution of DDT surveys. Direct detection technology is the revolutionary three-stage technology of oil and gas discoverer for direct detection and delineation of minerals and hydrocarbon-bearing formations in the subsurface of the Earth. DDT is a revolutionary technology for exploring the Earth from space using satellite images and from inside aircraft, usually helicopters, or directly on the surface of the Earth to identify and precisely locate oil and gas, as well as other Earth mineral deposits. With the initiation of DDT surveys, OGD is provided a customer-defined area with specified geographical coordinates, which is defined in a contract indicating cost and timing for the completion of the DDT Stage 1 survey and final report. DDT Stage 1 surveys are the initial identification of anomalous mineral or hydrocarbon-bearing deposits in the subsurface on a customer-defined area based on data obtained from satellite images. DDT Stage 2 surveys are field expeditions, usually a helicopter or ground-based surveys, of the anomalous deposits on the customer-defined area with data processing included in a final report. The report will include the presence of hydrocarbon-bearing formations and potential drilling recommendations for hydrocarbon-bearing zones. With the data obtained from a thoroughly analysed DDT Stage 2 survey, OGD can provide information on the exact location of deposit outlines and bedding depth of productive hydrocarbon horizons. In the final report, OGD will inform the customer of the depths, thicknesses and perimeters of the most productive hydrocarbon-bearing formations identified by DDT points of highest concentration of radiation with suggested points for drilling exploration wells. Performing the DDT Stage 2 survey makes it possible to correct the contours of the anomalies due to intrinsic emissions of hydrocarbons obtained during the DDT Stage 1 survey, rank them in terms of significance, and predict the results of drilling at sites with a probability accuracy of greater than 92%. If a customer determines to continue the exploration effort by drilling a wildcat well, OGD will offer the customer a DDT Stage 3 survey, in which OGD will send a specialist to walk the area of the selected drilling location with a specialist set of DDT field equipment, and will put a stake in the ground for an OGD recommended drilling equipment location. Here are images of the evolution of DDT stage surveys. The first image is customer's area of interest. The second image is DDT Stage 1 survey results. The third image is DDT Stage 2 survey results. And the fourth image is DDT Stage 3 survey results. Continue evolution of DDT surveys. The latest addition to the OGD DDT satellite surveys is our OGD DDT Star 1 and Star 2 surveys introduced in 2018. The DDT Star 1 survey has been developed to evaluate the occurrence of hydrocarbons and/or mineral deposits for very large prospects. The satellite images utilized in the Star 1 surveys are of a lower resolution. However, OGD remains capable of identifying hydrocarbon flashes at a high level of accuracy. These hydrocarbon flashes are indicative of areas with possible locations of hydrocarbon deposits in the subsurface versus areas with non-existent hydrocarbons and/or mineral deposits. The DDT Star 1 survey was specially designed and has been successfully implemented onshore and offshore areas in different parts of the world. The DDT Star 1 survey is followed by DDT Star 2 surveys. This entails additional use of low-resolution satellite images to better define the hydrocarbon and/or mineral anomalies in areas with prospects limited in areal extent of 1,000 to 10,000 km squared. The DDT Star 2 surveys are followed by DDT Stage 1 surveys, using high-resolution satellite images utilized to continue the more precise identification and delineation of hydrocarbon and mineral deposits in the subsurface defined by the Star 1 and Star 2 surveys. A customer engaged OGD to survey one of the states in the United States to find new prospective development prospects. OGD scientists decided to apply the DDT Star 1 and Star 2 surveys to large areas in the state of Oklahoma. These areas are essentially devoid of hydrocarbon-producing wells and coal-bed methane areas. The three areas chosen for the DDT Star surveys are identified as S, SE, and E, with S consisting of 7,766 km squared, SE consisting of 19,025 km squared, and E consisting of 11,006 km squared. The results of the DDT Star 1 survey are presented in Figure 2, with distinct hydrocarbon flashes recorded in all three of the OGD chosen areas to be surveyed. As stated before, these DDT Star 1 areas indicate the possible locations of hydrocarbon deposits. As can be seen in the Figure 3, The DDT Star 2 surveys support the discoveries from the DDT Star 1 survey, as well as a correlation with data from nearby existing oil and gas fields, enabling OGD to define the three areas S, SE, and E. OGD eliminated areas of Oklahoma with existing oil and gas fields and surveyed 38,000 kilometers squared using our new low-resolution satellite imagery for lower costs and less time-consuming DDT Star 1 and Star 2 surveys. The results of the data analysis and grading of hydrocarbon anomalies reduced the original area by about 70%, with the recommended prospective 3 areas for further more detailed DDT Stage 1, 2 and 3 surveys. The overall surveyed area is reduced to 10,200 kilometers squared. As shown on Figure 5, OGD recommends with a high probability of success that on the purple polygons labelled SS, SSE and SE, the customer will find significant amounts of hydrocarbons based on additional DDT Stage 1, 2 and 3 surveys. DDT Stage 2 survey data analysis and presentation. With the DDT Stage 2 survey data analysis and based on the scale of intrinsic radiation levels, OGD uses a primary designation of 5 colours with a lower white colour indicating essentially background noise. Based on the use of a maximum intrinsic radiation amplitude of 3.0, OGD has a proprietary way to analyse and grade levels of productive horizons in the subsurface, which includes the following. Colour number 1, red. Maximum level of intensity of subatomic particles of intrinsic self-radiation from the hydrocarbon formations. This level would have the highest output and commercial efficiency in the surveyed area. Colour number 2, blue. Moderate level of intensity of subatomic particles and intrinsic self-radiation from the hydrocarbon formations. Moderate level is classified as with 50% to 70% productivity level compared to level red. Colour number 3, green. Below the average level of intensity of subatomic particles intrinsic self-radiation from hydrocarbon formations. Below average level has weak hydrocarbon and water mixed formations and is classified as 10% productivity level from top level red. Colour number 4, yellow. Weak but higher than background level of intensity of subatomic particles, intrinsic self-radiation from formations with mixed low presence of hydrocarbon signals. Performing the DDT Stage 2 survey makes it possible to correct the contours of the anomalies due to intrinsic emissions of hydrocarbons obtained during the DDT Stage 1 survey, rank them in terms of significance, and predict the successful results of drilling at sites with a probability accuracy of greater than 92%. Based on the data obtained during the DDT Stage 2 survey, OGD will typically complete a final report with identification of the location of the highest hydrocarbon intrinsic radiation anomalies, a 3D presentation of the hydrocarbon deposit or deposits with the depth, perimeter, and approximate size of the deposit or deposits, as well as specification of drilling locations and anticipated depth emissions for encountering the hydrocarbon deposit or deposits. An example of a 3D presentation of the hydrocarbon deposits with depths in meters is presented below. The practical experience of OGD and our goal for DDT Stage 2 survey estimation of productive hydrocarbon horizons, depths to tops and bottoms, could have errors of approximately 5 to 7%, which depth estimations have been acceptable to our customers. In addition, OGD consistently provides customers with information and presence of productive hydrocarbon-bearing horizons with an accuracy of as much as 95%. The 3D block diagrams show the estimated depths and thicknesses of the potential hydrocarbon productive horizons up to 4.5 kilometres or about 15,000 feet. Each horizon has its colour correlated with the graded level of self-radiation intensity. A more simple 3D block diagram indicates the presence of only 4 hydrocarbon-bearing horizons with their thickness and relative depth from 0.5 to 4.2 kilometres. A more simple 3D block diagram indicates the presence of only 4 hydrocarbon-bearing horizons with their thickness and relative depth from 0.5 to 4.2 kilometres. DDT surveys completed in 2017 to 2019 outside the United States: Antigua and Barbuda, Kazakhstan, and Montenegro. DDT surveys completed in 2017 to 2019 inside the United States: Arizona with 1, Colorado with 4, Florida with 1, Idaho with 1, Illinois with 6, Nebraska with 1, New Mexico with 1, Oklahoma with 3, South Dakota with 1, Texas with 3, and Wyoming with 2.